Greetings, my name is Merlin, and today we're going to look at the magic number divisibility test for 7. It's one of the most important divisibility tests in the universe, and yet most math books will not show it to you. They apparently want to keep it a top secret. But shh, it's so important that I'm going to show it to you anyway. Why is it so important? Well, 7 is one of the very early prime numbers. Every composite number between 1 and 121 has 2, 3, 5, or 7 as a factor. And that means that any whole number between 1 and 121 that does not have 2, 3, 5, or 7 as a factor is automatically a prime number. You can bet that I taught this divisibility test to young King Arthur and to all of the knights of the Round Table and to the maidens as well. And now I'm going to share it with you. The divisibility test for 7 is called a magic number test because in order to use it, you have to know the magic number. Every prime number other than 2 and 5 has a magic number test, but the magic number is not always the same. The magic number for 7 is 2, but that is not an accident. I will even share with you a little secret, how you can figure out the magic number for 7 all on your own. We are looking for the first positive multiple of 7 that ends in a 1. Is it 7? No. Is it 14? No. Is it 21? Yes. 21 is the first multiple of 7 that ends in a 1. Now the magic number is not 21, it's the number that appears in front of the 1 in 21. And that is the number 2. So that's why 2 is the magic number for 7. We're going to look at several examples to show you how the magic number divisibility test for 7 actually works. Once you understand the test, I encourage you to pause the video and work out the problem for yourself. Then check back to verify your answer. After the examples, we'll state the overall rule, which hopefully will make perfect sense. Let's get started. Our first example will be 777, which you probably will recognize is going to turn out to be divisible by 7. Let's see how the magic number trick works. You look at the last digit, which is a 7, cross it off, and then multiply it by the magic number, which remember is 2. 7 times 2 is 14, and subtract 14 from what we call the truncated number, which is now not 777, but 77. We get 63. If we can recognize that 63 as being divisible or not divisible by 7, then we're done. Clearly, 63 is a multiple of 7, so 63 is divisible by 7, and we really could be done. But let's just pretend that we don't recognize that. So this is how the test would continue. We would look at the bottom number, cross off the last digit, multiply it by the magic number 2 to get 6, subtract from the truncated number to get 0, which clearly is divisible by 7. So whether we stopped at 63 or down at the 0, we have the same answer. Yes, 777 is divisible by 7. And this is the division work that we are saving ourselves the time of having to do. Our next example will be 1024, which you might recognize as 2 to the 10th power. And let's see if the magic number test for 7 verifies that it will not have any factor of 7. We cross off the last digit 4, double it to get 8, subtract from what remains. We get 94. You might be able to tell, but we're going to go one more step. Cross off the last digit 4 again, multiply it by 2 to get 8, subtract, and we get 1. Clearly 1 is not divisible by 7. So the original number, 1024, is not divisible by 7. This is the associated division problem that would also verify that. Notice that it appears that our work here using the magic number test is a tad bit simpler. Our third example is the number 91, which is interesting and important because, as it turns out, it is not a prime number even if it looks prime, and is one of those numbers that quite often we will make a mistake on. Let's see what happens with the divisibility test for 7. We cross off the last digit 1 multiplied by the magic number 2, subtract 2 from 9, and we get 7, which is obviously divisible by 7. Therefore, 91 is divisible by 7. Here is the actual division problem that would also verify that 91 is divisible by 7. If the original number that we're working with is longer, then the divisibility test might take a little longer, have more steps to it, but then again, so would the corresponding division problem. Let's see what happens here. Cross off the 6, double it to get 12, subtract. Cross off the 3, double it to get 6, subtract. Cross off the 7, double it to get 14, subtract. Now watch what happens here. When I subtract 16 from 10, I actually get negative 6. But negative 6 could also be eligible to be divisible by 7. It just turns out not to be. If we had negative 7 or negative 14, then we would say yes, it's divisible. But here we would say no. And here's the division problem that would perhaps take us, I would think, take us longer than if we had gone through this magic number test of 7. You might recognize 2,310 as being kind of an interesting number. It's the product of the first 5 prime numbers, of which 7 is one. So we should expect this to turn out. Let's see what happens. Now here we get 0 as the crossed off, and when we double it, we still get 0. So we subtract 0 from 231. Cross off the 1 and double it. Subtract, and we get 21. Clearly a multiple of 7, so this should be a yes. Again, we could carry it one step further. Double the 1 to get 2, subtract 2 and get 0. Remember, 0 is always a sign of divisibility. And there's the division problem that we have avoided. For our last example, I believe we have 7 to the 6th power, so it's loaded with factors of 7. Let's see if we can find at least one from our test. Double the 9 to give 18. Subtract. Double the crossed off 6 to make 12. Double the 2 to make 4. Double the 2 again to make 4. And we do get 7, which tells us, yes, the original number is divisible by 7. And of course, we know it's divisible by a lot of factors of 7. And here's the division problem that we would have done had we just divided and did not have this beautiful divisibility test, the magic number test for 7. I think we're ready now to look at the statement of the magic number divisibility test for 7. See if it makes sense based on the examples we looked at. First, you write down the number. Second, you cross off the final digit of that number and mentally multiply it by 2 because 2 is the magic number. Third, subtract that doubled number from the truncated original number. 4, if you can tell whether or not that new number, the bottom number, is divisible by 7, then you're done. Step 5, if you can't tell, then repeat the process by crossing out the final digit of the bottom number, doubling it, subtracting from the newly truncated number, and see if you can tell whether that number is divisible by 7. Continue the process as needed until you can decide if the bottom number is or is not divisible by 7. And the final conclusion, the original number will have the same divisibility with respect to 7 as the bottom number. If the bottom number is divisible, so is the original number. If the bottom number is not divisible by 7, then neither is the original number. And that's it. That's the magic number divisibility test for 7. In future videos, we'll be looking at a couple of tests for 11, the next prime number after 7. We'll also be looking at what prime numbers are all about, how to find them using the sieve of Eratosthenes, and the awesome secrets we can learn from prime factorization. If you enjoyed this video or found it helpful, please give it a like, subscribe to this channel, and hit that notification bell so you can receive notices of future videos. Thanks for watching and for your support.